1, which is without using a mathematical table or calculator, evaluate 0.13 times 0.3 minus 0.003 all over 0.09, giving the answer in decimal form. So here we have been given instruction that we have to adhere to, that we have to give the answer in decimal form. So this question is set from the topic of decimals, that is from one topic in mathematics. So let us solve the question. So first of all, we have to begin by simplifying the numerator. So if we simplify the numerator, which is 0.13 times 0.3 minus 0.003. So using board maths, multiplication comes before subtraction. So 0.13 times 0.3, that is actually 0.039. Then we subtract 0.003. So if we subtract this, we end up getting 0.036. So that's the value of the numerator, and then we are going to divide the simplified numerator by the denominator, and that is 0.036 all over the denominator is 0.09. So we want to get rid of the decimal, so we are going to multiply the denominator by 100. 0 has the number of decimal places, there are 2, so times 100. Also we do the same with the numerator multiplied by 100. So if we multiply by 100, so we shall end up getting, this will be 3.6, and therefore we have 9. So if we are going again to divide by 9, 1 by 9, 0.4. So the answer is 0.4. Remember strictly to give the answer in decimal form and not in fraction form. So that's how we go about question 1. Therefore, we are going to proceed to question number 2. And the question number 2 says we simplify the expression 4x squared minus 9 all over 2x squared plus x minus 6. So for this expression, we are going to begin by factoring out the numerator and also the denominator. So let us begin with factoring the numerator first, and then that value divided by the denominator. So for the numerator, we can see this is actually a quadratic expression, a form 3 topic in mathematics. So we have 4x squared minus 9. So we can be able to write this as a perfect square using a squared minus b squared is the same as a plus b multiplied by a minus b. So we can rewrite 4x squared as, so 4 is the same as 2 squared, so this will be 2x squared minus 9 can be written as 3 squared. So this is the difference between two squares, and this can be written as 2x plus, now if we say that a corresponds to 2x, b corresponds to 3, so that will be 2x plus 3 multiplied by 2x minus 3. So for that case, we shall use this in our final calculation. Then we have the denominator part. For the denominator part, again it's a quadratic expression, so that is 2x squared plus x minus 6. So we can use the factorization method. So remember, this is of the form ax squared plus bx plus c, a quadratic expression. And therefore, we can rewrite this as we have factor ac, which is minus 12, that is minus 12. So we can have factors of minus 12, which will be such that we get plus x or plus 1. So we are going to have 4 and minus 3. So we can work it out here. We write x in the expanded form. That will be 2x squared, then plus, now we write x in the expanded form. This will be 4x minus 3x, then minus 6. Remember, 4x minus 3x is the same as x. So we haven't changed anything. So this will be, we take into pairs and then we factor out. So 2x is common. So 2x squared divided by 2x, that is x. Then plus 4x divided by 2x, get 2. Then 3x minus 6. So we have minus 3 is common. So minus 3x divided by minus 3, we get x. Minus 6 divided by minus 3, we get plus 2. So this can be written as 2x minus 3 multiplied by x plus 2. So again here, so this value here of the denominator, that's what you are going again to divide. So we have now numerator divided by the denominator. So this will be 2x plus 3 multiplied by 2x minus 3 all over 2x minus 3 multiplied by x plus 2. So if we check both the numerator and the denominator, there is something which is common, which can cancel out. So we have this part and this part, which can cancel out, and therefore we shall remain with 2x plus 3 all over x plus 2. And that is the simplified expression, the answer for the simplified expression. So let us move on to the next question 3. For question 3, look keenly into this question. It is set from the equation of a straight line, that's from 2 mathematics. And it says a straight line L1 whose equation is y is equal to 2 minus a third x meets the y-axis at Q. Another straight line L2 is perpendicular to L1 at Q. Find the equation of L2 in the form y is equal to mx plus c, where m and c are constant. So, for this question, we actually require, since we have been given the equation of line L1 and meet the y-axis at Q, to meet the y-axis at Q. So, y-axis at Q, the x-coordinate of Q will be equal to 0, the point where the line L1 cuts Q. So, the x-coordinate at that particular point, x-coordinate of Q, is actually 0 at where it cuts the y-axis. And therefore, we can substitute into the equation given the value of x, which is 0. Therefore, y is equal to 2. Therefore, the coordinate of point Q is 0, 2. And also we can get the gradient of L1, of line L1, since we have been given the equation in the form of y is equals mx plus a constant. Therefore, gradient is equal to minus a third x. That is minus a third. And therefore, since line L2 is perpendicular to line L1 at Q, therefore we know that the gradient of a perpendicular line, their product is equal to 1. And in our case here, the gradient M1 of line L1 is negative a third. So we need to get the gradient of line L2, and the gradient of line L2 will be equal to 3, positive 3. Therefore, we can get the equation of L2. So we need the 2 points, and still the L2 passes through point Q, which is 0, 2. We can also have another point xy, which is on line with Q. And therefore, gradient change in y over change in x is equal to 3. We are looking for the equation of line L2. So that will be y minus 2 all over x minus 0 is equal to the gradient, which is 3. So this will be y minus 2 will be equal to 3x. We have to write in the form y is equal to mx plus a constant. So this will be y is equal to 3x plus 2. And this is the equation of line L2. We move to the next question, which is number 4. Question number 4. A circle of radius 3 cm passes through all the vertices of a regular hexagon. Determine the area of the circle that lies outside the hexagon. So for this case, allow me to draw a circle with the center O. And then I'm going to draw an hexagon. Hexagon has 6 sides or 6 faces. So therefore, this is the hexagon I'm drawing. So we are required to find the area lying outside the hexagon, and this is the area which lies outside the hexagon. Therefore, from the center of the circle, I can actually draw all triangles, subdivide the hexagon into triangles, and it has from 6 parts. So, if O is the center, then I have this point A, B. I can get this angle theta, and to get the angle theta, that is angle AOB, which is theta, will be equal to, angle at a point is 360. I divide by 6 faces, which is 60 degrees. Therefore, to get the area outside the hexagon, I have to get the area of the circle, then I get the area of the hexagon, and then I do the subtraction. And here the radius is 3. Therefore, area of circle that will be pi r squared, and therefore this will be, I will just give it in terms of pi, and therefore this will be pi times r is 3 squared, that is 9 pi centimeter squared. Then I also find the area of hexagon. Since it has 6 faces and there are 6 triangles which are equal, so I'll use the formula of AB sin theta. So I have AB, in our case it is radius, r squared sine theta, again times n, the number of triangles. So this will be a half times 3 squared times sin 60 times 6 triangles or 6 faces. So if you work this out using a calculator, we end up getting 27 root 3 over 2. 3 over 2. Again, here this would be the same as 28.2857 centimeter squared, or this could also be 23.3827 centimeter squared. Now, getting the area outside the hexagon, we are going to subtract, that is 9 pi, area of the circle, 9 pi minus 27 root 3 over 2 centimeter squared, or will be 28.2857 minus 23.3827. If we do the subtraction, this will be 0, 3, 0, 9, 4, and this will be centimeter squared. So that is the area outside the hexagon. Next question is question 5. Solve for x in the equation 25x raised to x is equal to 125 raised to 2 that divided by 5 raised to negative 1. So we are required to express both sides of the equation to the same base, So 25 raised to power x can be written as 5 raised to 2 and raised to power x. This is equal to 125 can also be written in terms of base of 5, 5 raised to 3, then to bracket raised to 2 third, divided by, we have 5 raised to minus 1. Now, we are going to open the bracket for the exponents. So this will be 5 raised to 2x will be equal to, now the exponent 3 times 2 third, so we get 5 raised to 2 divided by 5 raised to minus 1. We need to apply the rule of division of exponents with the same base. So we have the same base, and therefore where we have division we are going to subtract. So we have now to write this as 5 raised to 2x is equal to the right hand side. Now we have division. We are going to subtract. So that will be 5 raised to 2 minus 1. So in this case, we shall equate the exponents. We're going to equate the exponent. But before that, let us rewrite this as 2 raised to power 2x is equal to, this will be 5 raised to 2 minus 1, that is raised to power 3. So we are going to equate the exponents since the base are the same. So we have 2x is equal to 3. And therefore, follow that x is equal to 3 over 2, or that is 1.5. This topic question is set from the topic of indices. We move to question number 6. A carpenter had 2 big pieces of wood of equal length. The carpenter cut the first piece into smaller pieces of length 15 cm each without remainder. The carpenter cut the second piece into smaller pieces of length 24 cm each without remainder. Determine the minimum length of each of the big pieces of wood. So, for this case here, we have a keyword, determine the minimum length, and this is very important when we work out this question. So carpenter had 2 big pieces of wood of equal length. So one of them was cut into smaller pieces of 15 cm. The other one was cut into smaller pieces of 24 cm. And therefore, for us to get the minimum length, therefore we require to find the LCM of 15 and 24. So we can get the factors of 15, and the factors of 15 is 3 times 5, that's the prime factor. Also we can get the prime factor of 24, and the prime factor of 24, it is 2 raised to 3 times 3. Therefore, to get the LCM, we are going to take the common multiple with the highest power. So for this case, LCM of 15 and 24 will be, so we have 2 raised to power 3. 3 is common also, so times 3, and also 5 times 5. For if we multiply this, we shall get 120 centimeter. We can also go the tabulation way of finding the LCM of 15 and 24. We can start with the least prime number factor, which is 2. So one of these can be divided by 2. So by 2 this will be 15. We retain 15. This will be 12. Again by 2. This will retain 15. This will be 6. Again by 2. We retain 15. This will be 3. So now we have exhausted 2. Now we go to the next prime factor, which is 3. So dividing by 3, it goes 5. This will be 1. We have exhausted 3. So the next prime factor is 5. Divided by 5, we have 1. This is 1. So LCM is 2 times 2 times 2 times 3 times 5. So this is 2 raised to power 3 times 3 times 5, which is 120 centimeter. So the minimum length of each of the big pieces of wood must be 120 centimeters. So that whenever they are being cut, we can give a length of 15 centimeters without a remainder, or 24 centimeters without a remainder. We move to the next question, which is question 7. A cylindrical container of internal radius 10.5 cm has a hemispherical base. The container has water up to a height of 30.5 cm. Calculate the surface area of the container that is in contact with water. So we take pi to be equal to 22/7. So we have a cylindrical container. So let me just draw it. We have the cylindrical container. So the internal radius is 10.5 centimeter, 10.5, and it has a hemispherical base. So it has a hemispherical base. So the other information that we are given, the container has water up to a height of 30.5 centimeter. So we need to calculate the surface area of the container that is in contact with water. That is in contact with water. Now, remember, so it has a hemispherical base, and if the water being contained is up to a height of 30.5 centimeter, then it also includes the part height of that radius of that base, which is 10.5. So the remaining one, the part of the cylindrical part, will be 30.5 minus 10.5, which is 20. So that it gives a total of 30.5 centimeter. The trick is actually there. So a student needs to identify this, the radius of the hemispherical part, then that is also included in the 30.5. So the part of the cylindrical part that is in contact with water is 20 centimeter. Therefore, now we need to find the surface area of the container in contact with water. So we get the curved surface area of cylinder, and the curved surface area of cylinder is given by 2 pi r8. So the circumference times the height of that cylindrical part. So we have 2 times pi, we are being asked to use 22/7. Then the radius is 10.5 times height. Height will be 20 centimeter. So if you work out this with your calculator, you get 1,320 centimeter squared. Then we need also to get the surface area of hemispherical part in contact with water. So the formula is 2 pi r squared. 2 pi r squared. Remember, surface area of a sphere is 4 pi r squared, and this is a half of it. So we shall get 2 times pi is 22/7 times the radius is 10.5 to square it. So if you work it using a calculator, we get 693 centimeters squared. So the total surface area is, we had 1320 and also 693. So if we add to get the total surface area, will be 1320 plus 693. So this is 3102. Therefore, the total surface area is 2013 centimeter squared. Next is question on construction, geometrical construction. So in the following figure, point A and D are vertices of a trapezium AB, CD. Line DC is parallel to line AQ. Line BC is parallel to line AQ, and line BC is equal to 4 centimeter. Point B lies on the line AQ such that angle DCB is equal to 90 degrees. So we are supposed to use a ruler and a pair of compasses only to complete the trapezium and measure the length of line AB. So now we require point A and B are vertices of the trapezium ABCD. Line DC is parallel to line AQ, and then line DC is equal to 4 centimeter. Point B lies on the line AQ such that the angle BCD is equal to 90 degrees. So let us use a ruler and a pair of compasses only, so that we complete the trapezium, and then we measure the length of the line. So the first thing we should actually be able to do is to drop. We are going to drop a perpendicular from D to meet AQ at M. So we shall drop a perpendicular, so at this point from D. So we are going to draw a perpendicular. So let us put mark at this, the bottom there, and then so using this arc as the center, so I put another arc there, and also use this arc here, the center, and maintaining that radius, so I put another mark there. And therefore I'm going to join this arc and also point. So using a ruler, this point, so I'm going to draw that perpendicular line. So that is it. So label this point M. Once I do that, the next thing we shall do, now we have dm, that is the perpendicular line we have drawn from D. The next thing we need to also get is C. Now we have been told DC is parallel to AQ, and therefore we need also to locate point B, which lies on the line AQ, such that D is 90 degrees. But we don't know exactly where point B is, so we need to locate point C first, and from point D we can draw perpendicular to pass through D, to cut D perpendicularly. So at this point here, so that point, and also on the other side do the same. Then I'm going to bisect again. So using this arc here, I'm going to draw a perpendicular, an arc, bisect. So let me adjust the radius, so put a mark there, and also on the other side I do the same. Then I also use the other arc. I need actually to maintain the radius, so I'll have to use it this arc again, since I need to maintain the same radius. Fine. Once I do that, I'll take the ruler and draw that perpendicular line. Fine. Then I will draw the line. Then I need to locate point C. Something, let me do this correctly. So I need to locate point C, and point C is 4 centimeters from point D. Centimeter. So that's where point C is. Point C. So from point C, now I'm going to draw perpendicular. I'm going to draw perpendicular to meet AQ at B. Since angle BCD is 90 degrees. So it. And then I adjust to the radius, and using this as the center of the circle. In circle, I draw an arc. I draw an arc here. Also maintaining the same radius. Also draw an arc. So therefore, using a ruler, I join the arc and the point C. So this point B, that's point B, and therefore we are required to measure point AB. Hence, measure point AB. We have completed the trapezium ABCD, as this point is 90 degrees, and therefore we need to measure AB. So let us measure AB and see what we get. So that is 7.2, 7.2. So AB is equal to 7.2 centimeter. So the steps in doing the construction is very important, and that is actually what is expected. So we can move on to the next question, number 9. The length of a minor arc AB of a circle center O is 10 cm. The arc AB subtends an angle of 1.25 radians at O. Calculate the area of the minor sector AOB. So for this question, tested from area of part of a circle, and I will begin by making a sketch of the minor sector of the circle. So you have the center O, then arc AB, and the length of the minor arc AB, which is 10 cm, and angle in radian is 1.25 radian. So we need to find the area of the minor sector, the area of the minor sector. But since we don't know the radius first we need to find the radius, then we use the radius to find the area of the minor sector or B. That is minor sector, that is part of the circle. So area of A or B will be equal to pi r squared times angle in radians. So we don't require actually to change the angle in radians to degrees, but we can use it the way it is, and therefore, and to get the arc length will be given by, we don't know actually the radius, so we are after the radius, then we use this formula to find the area of the minor sector A or B. So arc length is given by 2 pi r times angle in radian. So arc length we have been given is 10, is equal to, let us substitute into this formula. So 2 pi is 22/7 times r, which we don't know, then times, now angle in radian, we know the all angle at a point, the all angle is 2 pi radian, but this is a fraction of it, so it's 1.25 over 2 pi, or 2 pi radians. So to get r, so it will be 10 times 7 times 2 pi all over 2 times 22 times 1.25, and pi here in our case it is 22/7 times 22/7. So if we work it out, so we shall get exactly radius is 8 centimeter. 8 centimeter. Now we can use that radius 8 centimeter to get the area of triangle sector A or B, which is pi r squared times radian angle. So pi is 22/7 times r is 8, so 8 squared times 1.25 all over 2 pi. Remember, we are doing this because it is fraction, it's a sector of a circle. So this is 22/7 times 8 squared is 64, this times 1.25 all over 22/7. So if we work it out, so we end up getting 40 centimeter squared, and that is the answer. So next we go to question number 10. Question number 10. So question number 10. The following figure represents part of a pattern. A line of symmetry L1 of the pattern is also shown. Complete the pattern and state the order of rotational symmetry of the pattern. Now, I'm going to use a compass and a ruler to complete the pattern exactly. Now, compass, let me measure this distance, and since this symmetry, so rotational symmetry is given by is equal to 360 divided by angle between identical parts of the figure. And for our case here, the angle between identical parts of the figure, so take this line here, it will be identical to this one. So for order of rotational symmetry is the number of times the figure fits into itself in one complete turn. So in one complete turn, how many times? If you take this part is A, this is B, and this one is C. If you rotate it, you'll find that A will fit into B, and also it will fit into C. That means for one complete rotation, it will fit 3 times. And if it fits 3 times, then this angle between two identical parts is 120. And therefore, the order of rotational symmetry is 3. It will fit 3 times in one complete rotation. So for question 11, a Kenyan bank bought and sold foreign currencies on 2 different dates as shown. So here is the table, and that is on 12th, that is in 1st of December 2021, 1 Southern African rand was being bought at 7.08 and being sold at 7.10. On 2nd of December 2021, 100 Tanzanian shillings was bought at 21.12 and 21.25. So a South African tourist arrived in Kenya on 12th 2021 with 15,000 South African rand. He changed the whole amount to Kenyan shillings, while in Kenya he spent a total of 53,075 shillings and changed the balance to Tanzanian shillings before leaving for Tanzania on 12/2/2021. Determine in Tanzanian shillings the amount he received. So for this currency exchange rate, the tourist actually had to, so since he arrived to Kenya, he had to change or convert the foreign currency to Kenyan currency, and therefore the bank was going to buy it at the rate of 7 shillings and 8 cents per rand, and therefore he received the amount that he actually received. So he received, so that is 15,000 times 7.08, and this amount to 106,200 shillings, Kenyan shillings. So while in Kenya he spent 53,075 shillings, so amount remained was, we subtract 106,200 minus the amount we actually spent 53,075, so we end up getting 53,125 shillings left. And now since you had to travel to Tanzania, then you had to change the Kenyan now to a foreign currency, which is Tanzania. So the bank will sell the Tanzanian currency to that particular tourist, and the exchange rate was to Tanzanian shillings. The rate was 21 shillings and 25 cents per every 100 shillings, and therefore the bank had to sell 100 Tanzanian shillings for 21 shillings 25 cents Kenyan shillings. So the amount she is going to receive is the 53,125 shillings. Now we convert to Tanzanian, that will be 100 all over. So this is what we take, 21.25. And if we work it out, so the amount she received in Tanzanian shillings will be 250,000 Tanzanian shillings. We move on to question number 12. The coordinates of points O, A, B, and C are 0, 0, 2, 1, 4, 4, minus 1, 7, respectively. The coordinates of point D is x, y. Point M is the midpoint of line CD, and it satisfies the vector equation OM is equal to OA plus 5 over 2 AB. So we determine the coordinates of point D. So this is an application question, vectors 1, and therefore from what we have been given here, OM is equal to OA plus 5 over 2AB. Now since we need to get the coordinates of point D, and the coordinates of point D is x, y, point M is the midpoint of line C, D. Now point CD, you know that we have been given point C, which is minus 1, 7. So let us draw this vector line, point C, which is minus 1, 7, and then point D, which is xy, M is the midpoint of CD, so we have point M is the midpoint of CD. So we can be able to get point M. But first, we need to get OM, we need also to get OA and AB. So those points will be very, very important for us to get. And therefore, so point OA, so to get point OA, it is the vector point column vector of A minus that of O. So for this one, it will be 2, 1, minus 0, 0. So the x coordinate is 2 minus 0, and then 1 minus 0, that is 1. So OA is 2, 1. Then we also get AB, vector AB. To get vector AB, the coordinates of B minus that of A. coordinates of B is 4, 4. The coordinates of A is 2, 1. Therefore, 4 minus 2, that is 2. 4 minus 1, that is 3. That's for B. Therefore, to get OM, it shall be OA, which is 2, 1, 2, 1, then plus 5 over 2, and AB is 2, 3. So this will be 2, 1 plus 5 over 2 times 2, we get 5. 5 over 2 times 3, we get 7.5. 7.5. Therefore, we need to add. So if we add 2 plus 5, we get 7, and 1 plus 7.5, we get 8.5. So that's for the position vector OM. Therefore, we need to get the coordinates of point D. Now, to get the coordinates of point D, in other words, since I drew this initially, so how can we be able to get the M is the midpoint of CD, and to get M, it's actually given by x1 plus x2 over 2, that's the general formula, plus y1 plus y2 over 2. So for this case, now we consider C and D. So we have minus 1 plus x over 2, the other one for y, 7 plus y over 2. So this must be equal to 7, 8.5. So 7, 8.5 must be equal to, can we arrange this, will be x minus 1 over 2, comma, this is y plus 7 over 2. So comparing the corresponding coordinates, so I have 7 will be equal to x minus 1 over 2. So this will be 14 is equal to x minus 1, and therefore x is equal to 15. The other case, comparing the corresponding coordinates of the y coordinates, so 8.5 is equal to y plus 7 over 2. So this implies that multiply both sides by 2, we shall have to be 17 is equal to y plus 7, and therefore y is equal to 17 minus 7, which is 10, and therefore point D, which is xy, is D, x is 15 and y is 10, and that is the coordinate of point D. Then question 13. The following figure, not drawn to scale, represent a communication mast. The mast has been divided into 4 equal parts. A point P is 30 meters from the foot of the mast on the same ground level. So that's what we have. So the angle of elevation of the third mark from P is 30. The angle of is actually 50 degrees. Calculate the height of the mast. So the angle of elevation with that mast from P is 50 degrees. We need to calculate the height of the mast. Now, here the angle is 50 degrees. So from that is it. This angle of elevation is 50 degrees. So let us get the height of the mast. Now, since they are divided into 4 parts, so let this distance be x. So this will also be x, this will be x, and this will be x. Now, to get the height of the mast, so we need to get, let's consider this height to be h. So tan, we're going to use the ratio of tangent. Tan 50 degrees is equal to opposite over hypotenuse. So h over 30, and therefore h will be equal to 30 tan 50 degrees. This 30 times tan 50 is 1.1918. Okay? So if you multiply by 30, you get 35.754 meters. Therefore, the height of the mast, since we said that let each part be x, then it simply means that here 3x up to the third mast, the 3x, x plus x plus x is equal to 35.754. Therefore, x will be equal to 35.754 divided by 3, and if we divide by 3, we get 11.918 meters. So, but to get the height of the mast is the 4x, so it will be 4 times 11.918, which will get us 47.672, that is meters, and that is the height of the mast. Then we move on to question number 14 on statistics. The following frequency distribution table shows the mass in kilograms of maize flour sold by 30 traders. Here is the table given: mass in kilogram, range 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59, and their corresponding frequency of the number of traders who sold the maize flour. So we need to calculate the median mass of maize flour sold. So since we need to calculate the median mass of the maize flour sold, we need to have a column for cumulative frequency. So in our case here is the mass in kg, that's what will represent x, and then number of traders, that is the frequency. So we need to have cumulative frequency for us to get the median. So we had the frequency cumulatively, so we have 3 plus 8, 11, 11 plus 10, that is 21, 21 plus 8, that is 20, plus 7, 28, 28 plus 2, that is 30. Now median position is n/2, which is 30/2 to get 15th position. Median class, so if you look at the median class, 15 is actually inside 21, because for the second this part is up to 11, so 15 is inside 21, so median class will be 32, 39, and therefore using the formula to find the median, it is a lower class boundary plus n/2 minus cumulative frequency preceding median term divided by cumulative frequency in the median value times class interval. So lower class boundary, here we have this the median class, the lower class boundary is 29.5 and plus n/2, that is 30/2, that is 15, minus cumulative frequency preceding the median class, this is 11, all over cumulative frequency of the median class, frequency of the median class is 10 times class interval 20 minus 10, which is 10, or 29 minus 90 is 10. So if we work it out, 29.5 plus 15 minus 11, that is 4/10 times 10, get 4. So we end up getting 34.5 kilograms. So that is the median value. Then question 15. The table below shows values of y and some values of x for the curve that is 0 is less than or equal to x, it is less than or equal to 3. So we are required to complete this table by filling in the missing value of y, and also we use the mid-ordinate rule with 3 strips to estimate the area bounded by the curve, the x-axis and the line. So we have the table which shows values of x and also some values of y for the curve. So we need to fill in the table. For the curve is y is equal to x squared. For the curve y is equal to x squared. Now let us complete the table by filling in the value of the missing part. When x is 1.5, that means y will be 1.5 squared, which is 2.5. So here it is 2.25. And the other part which is missing, when x is 2.5, y is 2.5 squared. Substitute into the equation, which we get as 6.25. So this is 6.25. Then we use the mid-ordinate rule with 3 strips to estimate the area bounded by the curve, the x-axis and the line. So for us to use the mid-ordinate rule, we need to get the width the width of the curve, and therefore to get the width we need to get the range of x, and then we divide by the number of strips. So the range is for x is 3, the maximum value of x minus minimum value of x, 0, divided by 3 strips. So 3 over 3, that will be 1. So the width of one strip is 1. Now to get the mid-ordinate are, so considering this very well, so the mid-ordinate will be at this particular point for x is equal to 0.5, 1.5 and 2.5. Since we are dividing them into 3 strips, so those are the value of x at the mid-ordinate. So x is equal to 0.5, 1.5 and 2.5. So the corresponding values of x. Now values of y when x is 0.2, then it shall be we substitute also into the equation given, y is equals x squared, so that will be 0.5 squared, the value of y1. This is x1 for x2, x3. So y1 will be 0.5 squared, which is 0.25. y2, that's when x is 1.5, it is 2.5. Then y3, when x is 2.5, y3 is 6.25. Now to get the area, using the mid-ordinate rule will be the width times the sum of the ordinates, so y1 plus y2 plus y3. So h, which is the width, is 1, multiplied by y1 is 0.25 plus y2 is 2. y2 is actually 2.25, so 2.25, then plus y3 6.25. So if you work it out, get 1 times, this is 8.75. You end up getting 8.75 square unit, and that is the area bounded by the curve, the x-axis and the line. And finally, to question number 16 of section 1 or section A. Use the Cartesian plane provided to solve graphically the simultaneous equation 2x plus 3y is equal to 1.2 and 5x plus 4y is equal to 1. Now we need to plot the two linear equation. 2x plus 3y is equal to 1.2 and 5x plus 4y is equal to 1. We are already given the scale, so we make use of the scale. And the easiest way to plot this, I'll just express these two equations in the form of x over a plus y over b is equal to 1, whereby a is the x-intercept, b is the y-intercept. So let me begin with the first one, which is 2x plus 3y is equal to 1.2. Let me make the right hand side be equal to 1, so I divide each term by 1.2 divided by 1.2 divided by 1.2. So I will end up getting, for this I will end up getting, this will be x over, that will be x over 0.6, x over 0.6, then plus 3y over 1.2 by 3, 1 by 3, 0.4. So that is y over 0.4 is equal to 1. Then the other equation, 5x plus 4y is equal to 1. Since already the right hand side is equal to 1, then I need to multiply this one. I divide by, in other words, I just multiply by 1 over 5 and also 1 over 5. So this will be the same as x over 1 over 5 plus this is y over 1 over 4 is equal to 1. So this can be written as x over 1 over 5 is the same as 0.2 plus, and this is y over a quarter is the same as 0.25. Fine. Now, so this is the equation I'm going to use, and this one, then to plot the points. Now, the first one, x-intercept is 0.6, so I'm going to put a mark here, 0.6, and then y-intercept is 0.4, that point. Then I use a ruler and I join the points. Then I label it as the original equation is 2x plus 3y is equal to 1.2. Then the other line, x over 0.2, 0.2 is the x-intercept, that point, and then y-intercept is 0.25, 0.25 is at this particular point, exactly that point. Therefore, I also use a ruler and I join. So that is it. I also label it as 5x plus 4y is equal to 1. So now I have plotted the two simultaneous equation, and we need to solve it. So the point of intersection of these two lines, that is the value. So at that particular point where they intersect, so that's where we get the values of x and also the value of y, and we would have solved it graphically. So the point of intersection, so here is where the point of intersection is. That's where the point of intersection is, and therefore so from this point downwards we read the value of x, and on the other side we do the same with the value of y. So for this, the value of x here is actually approximately 0.26, that is actually negative 0.26. Then the other one, the value of y, that is 0. Remember, one small square represents 0 point, that will be 0.02, and this will be 0.58. So that is the solution for the simultaneous equation graphically. So thank you so much for watching this section A. So stay tuned, and I'll be able to post section B in the next session. And thank you so much. God bless you.